So yesterday we focused on the power rule, and we learned that if you have a function raised to the nth power, you bring the power down in front and you subtract 1 from that power. So that created n to the x minus, or n to the x and minus 1. That is our power rule. Today we have the product rule. The product rule says that we can now find the derivative of two functions being multiplied together. Yesterday, when we had a product type rule, I told you you had to FOIL and then find your derivative. So last night in the homework on 15 and 16, you had to FOIL the two functions together and then take their derivative. So what we're going to do today is look at how we could take the product using the product rule. Before we do that, let's just review our power rule by looking at two functions, f and g. And what we want to do is subtract f from g and then take their derivatives. So we know that the derivative of the difference of two functions is the difference of the derivatives of the two functions. So if I have f of x and g of x, find the derivative by using two different methods when we are trying to find their difference. So our goal is we want to subtract them and find the derivative of their subtracted problems. So the first thing we're going to do is method 1. So method 1 says find the derivative of each and then subtract them. So the derivative, we have f of x equals x squared minus 2x. So its derivative would be 2x minus 1. And then you want to find the derivative of g. So g of x is 3x squared. Oops. Yeah, it would be 2x minus 2. Problem. Okay, and then g is 3x squared plus 4x plus 5. So you get 6x plus 4. So once you find the derivative of each, then you can subtract their derivatives. So it would be f prime of x minus g prime of x, which is 2x minus 2, minus, here's where algebra is important, it's the quantity of 6x plus 4. So that's really like 2x minus 2 minus 6x minus 4, which is negative 4x minus 6. Method 2 says we could start by subtracting the two functions and then take their derivative. So we want to take f of x minus g of x, which is x squared minus 2x, minus the quantity 3x squared plus 4x plus 5. So you have x squared minus 2x minus 3x squared minus 4x minus 5. X squared minus 3x squared is negative 2x squared. Negative 2 and negative 4 give you negative 6x minus 5. Now, you want to find the derivative of our new function. So it'd be negative 4x minus 6. Do my two answers from method 1 and 2 match? Yes. So does it matter if you derive then subtract or subtract then derive? No. So that's really nice. That's the same is true for adding them. The same is not true for multiplying. So what we want to do is compare the similar methods for the product. So it says, notice that the answers are the same. This is called the difference rule. So yesterday we had the power. This is the difference. Now we're doing the product. Is it true that the product of the derivatives is equal to the derivative of the product? Is it true that the product of the derivatives is equal to the derivative of the product? And the answer is going to be a no. So, for example, we have f and g. The derivative of f is 2x squared plus 3. So f prime is 4x. G is 4x minus 1. Its derivative is 4. So if you multiply their derivatives together, what do you get? 16x. If we did it the way I told you you had to do it yesterday, so yesterday if you had 2x squared plus 3 times 4x minus 1, and I told you find the derivative of that, what did you have to do? Find the derivative of two things being multiplied together, what do you have to do? FOIL. 2 times 4 is x squared times x is 2 times negative 1. 3 times 4. 3 times negative 1. Okay, so here's their stuff boiled together. Then you took your derivative. So what's the derivative of this? Is that derivative the same as those two numbers multiplied together? No. So that's kind of like all this was in that box over here for you, but I wrote it down. So the product of their, and then their derivatives is equal to this. This is the right answer. This is the right answer. This is bad. So the derivatives product is bad. The product and then the derivative is correct. Does that make sense? So you can FOIL and then derive. Or you can learn our cute little rule. Which is on the back. This is probably the rule you're going to use and memorize. Which says, if you want to find the derivative of one function times another function, then the product rule states it's the first times derivative of the second, God bless you, plus the second times derivative of the first. So here's your first, here's your second, first, second, first, second, first, derivative of the second, plus second, derivative of the first.
That's how much time.
Yeah. First times derivative of the second, plus second times derivative of the first. Say it with me this time, because every time you do a product rule, you will be saying this in your head. So, first times derivative of the second, plus the second times derivative of the first. Ingrain that in those brains.
Is sine the derivative of cosine? Or is cosine the derivative of sine?
TBD.
I think it's cosine's the derivative of sine.
Or maybe both are somewhat true. You just have to add some negatives and positives in there.
The derivative of each other. Got it. Okay.
Okay, so yesterday, if you wanted to do this, you had to FOIL, and then you had to derive them. We can essentially eliminate that aspect, and now use the product rule. So we will say now that y prime is equal to the first, So x squared plus 1 times the derivative of the second. The derivative of x cubed is?
3x squared.
Good. What's the derivative of 3?
0.
Plus, so think product rule plus the second, which is x cubed plus 3, times, what's the derivative of the first? Now, you'll distribute and combine like terms. 3x squared times x squared is 3x to the 4th. 3x squared times 1 is 3x squared. 2x times x cubed is 2x to the 4th. 2 times 3 is 6x. So we get 5x to the 4th plus 3x squared plus 6x. Okay? First times derivative of the second plus second times derivative of the first. So the first is the square root of x plus 2x. Do you see why foiling a square root would not be fun? So first times derivative of the second, derivative of 2x squared is 4x.
What was that?
Derivative of 2x squared plus 2x squared plus 5. Derivative of the square root of x. So we did that yesterday. Yeah. So keep it simple until we totally simplify. So 1/2 x to the negative 1/2 plus 2. X square roots of x, so if you multiply these together, you could write it as 4x square roots of x. X square roots of x could also be rewritten as 1. This is like a 1, that's like a 1/2, so you add them, so 1.5 becomes, so it's like saying 3/2. So x square root x is the same as x to the 3/2, just to give you that idea. 4x times 2x is 8x squared. 2x squared times 1/2 x. What's 2 times 1/2? How about x squared times x to the 1/2? What do you do to those? You multiply x squared times x to the 1/2. Or negative 1/2, sorry.
You add them, you get 1.
Which becomes a like term. You see why I kind of had us rewrite it? So this 2 times 1/2 becomes 1. X squared times x to the negative 1/2 becomes x to the 3/2. So we've done the first. Now we got to do outer. So you get 4x squared. Your inside 5 halves x to the negative 1/2. And the last is a 10. So I have room. So again, this is like x to the 3/2. This is like x to the 3/2. 4 plus 1 gives you 5x to the 3/2. No other x squareds. Oh, yes, there were. 4 and 8 gives you 12. So done, 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 done. What do we want to do to a negative exponent? Drop it down to the denominator. There's our answer. Okay. Example 3, I personally do not like fractions. I would probably change each of those 1 over x's to x to the negative 1 before I took my derivative. Now I would derive it. So you have first times 3 to the second plus second times 3 to the first that's lots of math. Now I have to FOIL twice. So do you see where the product rule may not have been the smarter choice in this case? So that's kind of like the point of the problem. Like this problem's really gross and icky. What do I have to do twice if I do the product rule? Exactly. So if you get to a problem like this, you're like, oh, like this is getting really, really gross. Go back and do it from the beginning. So like, look at it and be like, that's rougher than if I would have just started here and said, okay, let's FOIL this. So the first, x to the negative first times x to the negative first. You add them together, right? So negative 1 plus negative 1 gives you negative 2. Outer, x cubed and x to the negative 1 give you x squared. Inner, x squared and x to the negative 1 give you x. And last, you get x to the 5th. Oh my goodness, this is going to be so much easier to take as a derivative than the product rule of the product. So now when I derive this, I get negative 2x to the negative 3 plus 2x plus 1 plus 5x to the 4th. All we have to do is clean up that negative exponent. I don't care the order you write them, they don't have to be least to greatest. Typically, if it's multiple choice, it will be, but you can kind of process of eliminate and get yourself to that. That kind of opens up a door, right? Is always using the product rule the smartest decision then? No. So it becomes a thing of recognition. If simplifying first by FOILing makes the problems easier, then you can still do that. So when I got to this and I realized, oh my goodness, I have to FOIL twice and I have all these negative exponents, I said, all right, let's go back to the beginning and try FOILing to start. It's a process with which you kind of have to change what you're doing sometimes. So keep that in mind as you work through problems or you work through homework and you recognize those types of changes. We're going to talk about first, second, third, fourth. You saw in our chart, we can take derivatives more than once. So those are called higher order derivatives. The first derivative we represented as f prime of x. How do you think we represent the second derivative? The third? the fourth, which we rarely get to. What you didn't realize is when we're saying primes, we kind of draw them as a comma type thing. But really, yeah, yeah, so like apostrophe. I'm like, I can't think of the word. It was killing me. It's really Roman numerals. Yeah. We have Leibniz notation. That's where it's the dy dx. Hidden within this is saying the derivative of y with respect to x. The next one becomes d2y, which stands for the second derivative of y with respect to x twice, so it becomes dx squared. So it's the second derivative of y with respect to x twice. So it's kind of like saying dx times dx, which would give you dx squared, and then d squared. So what do we think the next one is? Dx cubed. Think in terms of physics. If the original function is position, its derivative is the derivative of velocity becomes. Anybody know what the derivative of acceleration is?
Sure.
Yeah. Derivative of a jerk. Snap. Not very good snapper. I honestly forget what I did with this one. I think this was just like the Y's, which are kind of silly. Like it's like 5 crown, 5 double crown, 5 triple crown. These are the two most common, the top two. They're the ones you're going to see all the time.
Are we allowed to interchange them? So, like, if they give a problem given, like dy over dx, go right at prime x and
Yeah.
they mean the same thing.
Mm-hmm. We're going to get to a unit where you have to use this. We're going to have two. We'll have related rates and we'll have implicit, because implicit will be like, we'll be deriving x's and y's simultaneously. So we'll actually get to a point where we have dx dx, because we'll take the derivative of x with respect to x. And then we'll look at, like, we actually take the derivative of Pythagorean theorem with respect to time. So it becomes like dA dt equals dB dt minus dC dt. Like, it has like 3 different variables up top and all the same bottom. So there will be a time you have to use certain notations, but yeah, for now everything is interchangeable. One last problem. We have f of t given to us. This would kind of be like your position of a particle. Find its derivative. So find f prime of t. So derivative of t cubed becomes 3t squared minus 12t plus 9. That's your first. Then it asks you to find the second. So now we take the derivative of this. So 3 times 2 is 6t minus 12. Your third derivative of 6t is, yep. I know it doesn't ask it. What would the fourth be?
0.
Yep. So ultimately, you kind of run out of derivatives, right? Like there will be functions that can run out of a derivative. You can see how each of these functions went down. Cubed becomes squared, squared became linear, linear became constant, constant became 0.
So what are, say you're doing this, you start out with velocity in the first one, then you get to acceleration in the second one.
Mm-hmm.
Sure. Snap. What is snap in units? Like how is that?
Like
It's just
meters per second, per second, per second, per second. One.
Can you ever like skip like jerk like straight to snap sometimes? Or like if you go from like snap to acceleration, like by taking derivatives, or is it always?
Well, snap to acceleration, you have to take intervals, right?
Yeah, you have to work backwards.
That'd be but like let's say
You can't skip. You can't go like velocity to jerk. You have to take the derivative of acceleration in the middle.
Is there any use for jerk?
Ask Mr.
The back of the physical says for car manufacturing.
6 points.
That's 6. So stressed.
oh my god.